Hey there, and welcome. Today we're going to tackle a concept in thermodynamics that, let's be honest, is a major stumbling block for so many students in exams like the GE. It's all about the properties of a system. Mastering this isn't just about getting a better score. It's about building a really solid foundation for everything else that comes after. So, let's just jump right in with a question for you. Take a look at these properties: mass, volume, temperature, and density. Now, just think for a second. If you were to double the amount of a substance you have, which of these properties would also double? The answer to that, well, that's at the very heart of what we're talking about today. It seems so simple, but this exact classification is a classic trap in the JEE. But hey, that's why we're here. By the end of this session, you're going to have a rock-solid way to figure out any property an examiner decides to throw at you. So let's really master this together. So how do we crack this puzzle once and for all? Well, it all comes down to one single powerful idea. I call it the division test. Seriously, if you only remember one thing from our entire chat today, make it this. This one test is going to be your guide for pretty much everything else. And here it is. The experiment itself, it's actually super simple. You just take any system with any property you want to analyze, and you ask yourself this one question. What happens to the value of this property if I just cut the system into two equal halves? That's it. The answer to that question tells you everything you need to know. Okay, let's actually try this out. Picture this. You have a container with 10 kilograms of water. It's taking up 10 liters of space, and it's at a nice hot 90 degrees Celsius. Now, in your mind, just slice it right down the middle, creating two equal parts. Let's look at just one of those halves. Well, the mass is now 5 kilograms, right? And the volume is 5 liters. But what about the temperature? The temperature is still 90 degrees Celsius. It didn't get cut in half. It didn't change at all. And just like that, you've perfectly illustrated the core definitions. Properties like mass and volume, the ones that changed when we divided the system, we call those extensive properties. You can think of it like they depend on the extent or the size of the system. And properties like temperature, the one that stayed the same, we call that an intensive property. Its value is totally independent of how big the system is. It really is that simple. All right, so now that we've got our fundamental tests down, let's make this a bit more formal and start building out these categories. Seeing some more examples is really going to help this concept click for you. Here's a quick side-by-side. On the one hand, you have extensive properties. These depend directly on the amount of stuff you have. This also means they're additive. If you've got two blocks of steel, you can add their masses together to get the total mass. Simple. But on the other hand, intensive properties are completely independent of the amount. They're more about the character of the substance itself. You can't just add the temperatures of 2 cups of coffee to get a super hot coffee, right? It just doesn't work that way. So what are some of the big, extensive properties you're going to see? Well, you've got the obvious ones: mass, volume, and the number of moles. But look closely here. This is really important. Notice all the energy-related terms: internal energy, enthalpy, entropy, and Gibbs free energy. This is a huge takeaway. Pretty much all energy-related terms are extensive. It makes sense, right? More matter means more total energy. Heat capacity also fits in here because it obviously takes more heat to warm up a big swimming pool than a small cup of water. Now for the intensive side of things. We already know temperature and pressure are on this list. Density is a classic example. And here's another super important rule to remember. All concentration terms, things like molarity or pH, are always intensive. It doesn't matter if you have a tiny drop or a giant vat of a solution. Its molarity is the same throughout. The rest of these, like surface tension or viscosity, are just built-in properties of the material itself. They don't care how much of it you have. Okay, the basics are down. Now let's get into the good stuff, the rules and the shortcuts that are absolutely essential for solving problems fast, especially when you're under the pressure of an exam. These are the kinds of patterns that the people who write the JEE just love to test. So check this out. There's this incredibly powerful shortcut I call the per unit rule. If you take any extensive property and you define it per unit of something else, like per mole or per gram, it instantly flips and becomes intensive. So why does that work? Well, you've basically just removed the size dependency by fixing the amount you're talking about. This little trick is a total game changer. And that rule leads us to an awesome exam hack. If you're scanning a question and you see the words molar or specific in front of a property, you can stop thinking right there. It is always intensive. Molar just means per mole. Specific means per unit mass. Think of them as a green light, an instant giveaway that the property size dependency is gone.
Okay, here's another mathematical rule that you'll see tested all the time, so you really need to lock this one in. If you take any two extensive properties and you make a ratio out of them, divide one by the other, the new property you get is always, always intensive. Let's break this down with the best example out there, density. We already know for sure that mass is extensive. We also know that volume is extensive because more stuff takes up more space. Now, what's the formula for density? It's just mass divided by volume. So what do we have? We have an extensive property divided by another extensive property, and the result, just like our rule says, is that density is an intensive property. This logic works every time. All right, let's lay out two more super useful big picture rules. First, like we said before, all of those energy terms, internal energy, enthalpy, you name it, they are all extensive. More stuff means more energy. And second, all concentration terms, molarity, molality, pH, all of them are intensive. The concentration of a salt solution is the same whether you take a spoonful or a bucketful.
This is so important because examiners love to trip you up with things that sound similar. Just look at this table. Heat capacity is extensive. It depends on how much mass you're heating. But the moment you see specific heat capacity, you know it's intensive because of that keyword. Same with electricity. The resistance of a wire is extensive. A longer wire has more resistance. But the EMF of a battery? That's intensive. It's based on the chemistry inside the battery, not how big the battery is. All right, theory's one thing, but the real question is, can we actually use this stuff to solve a problem? Let's tackle a typical JEE style question and see how our framework makes it much, much easier. So here's a question straight out of the JEE playbook. How many of the following are intensive properties? And the list is volume, molar enthalpy, temperature, Gibbs free energy, density, pH, and number of moles. Go ahead, take a second, look at that list, and try applying the rules we just talked about. Here's how you attack a problem like this every single time. It's a simple three-step process. First, just scan the list and knock out the obvious extensive ones. Volume, depends on size, it's out. Gibbs free energy, it's an energy term, so it's out. Number of moles, clearly depends on the amount, so it's out too. Step 2, we hunt for our instant intensive keywords. We see molar enthalpy, that's 1. We see pH, a concentration term, that's 2. And of course, temperature is always intensive. Finally, step 3, we check for any ratios. And there's density, which we know is mass over volume, extensive over extensive, so it's intensive. And just like that, we have our answer. Following that simple strategy, we found 4 intensive properties. Molar enthalpy, because of the keyword, temperature, which is always intensive, density, because of our ratio rule, and pH, which is a concentration term. The final answer is 4. See how a clear strategy just cuts right through the confusion? Okay, we've covered a ton of ground here, from the basic ideas all the way to some exam-level tricks. Let's boil it all down into a final checklist that you can use for a quick review anytime. Here it is, your master checklist. First, the division test. That's your rock, your foundation. If you're ever confused, just go back to that simple thought experiment. Second, the basic definition. Extensive depends on size, intensive does not. Third, remember those magic keywords, molar and specific. They are your ultimate shortcut. Fourth, that crucial math rule. Extensive divided by extensive is always intensive. And finally, remember our 2 big categories. Energy is extensive and concentration is intensive. Before we finish up, I'll leave you with a little something to think about. We know that extensive divided by extensive gives you an intensive property. So what do you think happens when you do the opposite? What kind of property do you get if you multiply an extensive property, like mass, by an intensive one, like specific heat? Think about it. Really understanding these relationships is the key to going from just knowing the definitions to truly mastering the concept.